Welcome to the History at Night channel. Here, time flows slowly, words become softer, and the past comes alive to help you relax and drift into sleep. Together, we will turn the pages of history from grand civilizations to quiet, forgotten episodes rarely mentioned in textbooks. Each story is told in a way that soothes your mind and eases away the tension of the day. Before we begin, don't forget to subscribe and give a like. It matters because by the end of our lecture, your eyes will feel heavy. Your thoughts will. Grow calm and sleep will come naturally and gently. Close your eyes. Take a deep breath. Allow yourself to let go of the day's worries. History is about to begin. And by the end, you may discover surprising truths that will change the way you see the past. Welcome to tonight's journey into the mysteries of the Bermuda Triangle. This stretch of the Atlantic Ocean has been wrapped in legends for more than a century, drawing the curiosity of researchers, sailors, and dreamers alike. Over the past 200 years, ships have sailed into these waters and never returned. Planes have disappeared mid-flight, leaving no wreckage behind. Rescue missions often came back empty-handed, and every unanswered question gave rise to new myths, from tales of supernatural forces to theories of unusual natural phenomena. But behind every legend stands a real event, waiting to be understood. Tonight, we will take a calm, thoughtful look at the Triangle. We'll explore the archives, listen to the voices of eyewitnesses, and carefully follow the facts. We'll walk through episodes where technology failed on clear days, where radio signals fell silent without warning, and where entire crews vanished without leaving a single clue. These stories often became surrounded by fiction, but together, we will separate truth from imagination. Step by step, we'll travel back to the very first mentions of lost ships, follow the mystery through the 20th century, and explore modern attempts to explain what might be happening here. With each case, we'll ask, was it nature, human error, or something else entirely? To understand the scale of the mystery, we should first draw its map. The Bermuda Triangle lies in the western Atlantic, connecting Miami, the islands of Bermuda, and San Juan and Puerto Rico. Its waters cover more than 1.5 million square kilometers, an area as vast as France and Germany combined, or nearly half the size of the Caspian Sea. For centuries, these waters have been alive with movement, trade routes linking the old world with the new, planes soaring between continents, ships charting busy courses. Yet, it is here that the Unexplained found its home, shaping one of the most enduring legends of modern times. So close your eyes. Take a slow, deep breath. Tonight, we will drift into the chronicles of the Bermuda Triangle, peeling back the layers of story and speculation, and searching gently for the truths hidden beneath. Our journey begins in the 19th century. As this part of the Atlantic Ocean was beginning to gather stories that stretched beyond the ordinary, one episode stood out and soon became a maritime legend. The encounter of the British ship Ellen, Austin with a drifting schooner in 1881. It was a tale full of details that gave it the weight of myth. Ellen Austin was crossing the Atlantic along a route that passed through the region between Miami, the Bermuda Islands, and Puerto Rico. She was a Victorian-era merchant vessel, a wooden hull reinforced with iron brackets, tall masts carrying tightly drawn sails, and a crew of seasoned sailors accustomed to the whims of the ocean. The day it all happened began like any other. The sun was high, glinting off calm waters. A gentle breeze carried the ship forward, and the horizon seemed endless. Then, at some point, a schooner appeared ahead, a small vessel adrift, showing no sign of life. Its sails hung loose as, if untouched for a long time, the mast swayed lightly with the waves, and the deck looked deserted, as though the crew had simply vanished into thin air. For sailors of that era, such a discovery was not entirely unusual. Ships were sometimes left without crews because of storms, pirate raids, or outbreaks of diseases such as cholera that could wipe out men at sea. A vessel like this could either be a rescue opportunity or a prize, to be towed to port and sold. For reward, the captain of the Ellen Austin decided to follow maritime tradition and sent men aboard. A group of sailors lowered a boat and rowed toward the mysterious schooner. Waves splashed softly against the sides. As they climbed a rope ladder and stepped onto its deck, the inspection revealed the schooner to be in excellent condition. The hold was filled with cargo, perhaps bales of wool, crates of tobacco, or casks of rum, neatly arranged and secured with ropes, as if recently checked before setting sail. The sails, though slack, were intact. The rigging was unbroken, and the wheel turned with only a faint creak, but no resistance dot in the cabins. There were signs of human presence: a worn book left open at the middle, a woolen cloak, a copper pipe, with traces of tobacco resting on a table beside a pewter mug. There were no marks of violence, no bloodstains, no broken planks, no flooding. The schooner looked as though her crew had left calmly of their own accord, abandoning everything. In place, the next case, connected with the Mary Celeste, adds new colors to this chain of unexplained encounters in the same waters. The Mary Celeste left New York in November 1872, bound for Genoa. She was a two-masted brigantine built in Canada, crewed by 10 people: Captain Benjamin Briggs, his wife Sarah, their 2-year-old daughter Sophia, and 7 sailors. In her hold were barrels of denatured alcohol destined for Italian buyers. The voyage began under clear skies with favorable winds, and everything suggested an ordinary crossing of the Atlantic. On December 4th, the British ship Dei Gratia, sailing from New York to Gibraltar, sighted the Mary Celeste hundreds of miles from the Azores near the edge of what would later be called the Bermuda Triangle. Captain David Morehouse, who knew Briggs personally, noticed that the brigantine was sailing erratically. Her sails were only partly set and the wheel swung loosely. Signals brought no response, and Morehouse sent 3 sailors in a small boat to investigate. Climbing aboard, they found emptiness. The crew was gone, yet the ship itself was in sound condition. The barrels of cargo remained in the hold, with only one broken while the others were intact. The sails and masts were unharmed. The hull showed no damage. In the captain's cabin lay navigational instruments, a chart marked with a position from November 25th, Sarah's sewing machine, and the little girl's toys. The sailors' bunks were made, their trunks with clothing and tobacco untouched. The logbook ended on November 25th, giving coordinates near the island of Santa Maria. The ship's lifeboat was missing, and the ropes had been cut cleanly. The compass was broken, and in the hold there was about 1 meter of water, though not enough to endanger the vessel, and the pumps were working. Food, money, and valuables were all left behind. The Dei Gratia towed the Mary Celeste to Gibraltar, where an inquiry began. British authorities examined the ship and questioned Morehouse's crew, but found no evidence of violence or disease. The alcohol cargo was declared safe. The case spread quickly through newspapers. Drawing attention to the region. The story of the Mary Celeste survives in official records of the Gibraltar investigation and in publications of the British press of 1872, including the Times. These sources are considered reliable, as they were based on testimony and inspection, yet the absence of witnesses from the Mary Celeste leaves gaps. The inquiry did not establish the true reason for the crew's disappearance, and explanations vary. Some suggest panic caused by alcohol fumes, though analysis disproved this. Others point to a storm, yet weather reports show calm seas. A third theory holds that the crew abandoned ship in the lifeboat out of fear of flooding, due to the water in the hold, even though the level was not critical. This version of mistaken fear leading to evacuation is considered the most plausible, given the dismantled pump and lack of other threats. Ahead of us lies the story of the Cyclops, whose fate in the 20th century revealed new dimensions of these mysterious disappearances. In 1918. At the height of the First World War, the American collier Cyclops added a new chapter to the chronicle of vanishings in these waters. Unlike the sailing ships of the past, this vessel was a massive steel steamship, yet its disappearance proved just as inexplicable. The Cyclops belonged to the United States Navy and was used to transport coal and ore. She was 165 meters long, with a total of 309 people on board, including sailors, officers, and several civilians, among them the U.S. consul in Rio de Janeiro. On March 4th, 1918, the ship departed from the port of Barbados, bound for Baltimore. Her cargo consisted of manganese ore, a heavy material vital for the steel industry and essential in wartime. The weather that day was favorable, with light winds and clear skies, and the ship had recently passed inspection in port. The Cyclops was last seen leaving the harbor of Barbados. Radio contact with the vessel continued during the first days of the voyage, but then suddenly ceased. No distress signals were received, and no reports of engine trouble, cargo issues, or bad weather were ever made. Somewhere between Barbados and the east coast of the United States, within the zone of the Bermuda Triangle, the ship simply vanished. Search operations began when the Cyclops failed to arrive in Baltimore on its scheduled date, March 13th. The U.S. Navy dispatched ships and aircraft to scour the route, but no trace of the vessel or the 309 people aboard was ever found. The ocean lay empty, as though the ship had dissolved into its vastness. The official investigation, organized by the U.S. Navy, was hampered by the complete absence of evidence. The Cyclops had been considered a reliable vessel, built in 1911 and was under the command of Lieutenant George Worley, an experienced officer. However, his German origins later fueled rumors of sabotage, rumors that were never supported by any facts. The weather in March 1918 along the route remained stable, with no severe storms, according to meteorological reports. The cargo of manganese ore was considered secure, and overloading was ruled out based on previous voyages. The history of the Cyclops is preserved in official records of the United States Navy and in publications of the American press of 1918, such as the New York Times. These sources rely on naval data and eyewitness accounts from Barbados, but the absence of wreckage or radio communications leaves many mysteries. Explanations vary. Some point to a sudden storm not reflected in the weather records. Others suggest an attack by a German submarine, although enemy activity in that area was not recorded. A third theory cites cargo instability or engine failure. The investigation did not determine a precise cause, and no hypothesis received conclusive evidence. The most plausible version is that of a hidden technical fault, possibly a hull fracture under the weight of the ore, which could have led to rapid flooding. Cases like the Cyclops, which disappeared in 1918, left behind a trail of mysteries that defied explanation. Each such incident, from the sailing ships of the 19th century to the steel vessels of the 20th, became a puzzle surrounded by speculation. The waters of the Atlantic preserved these stories, and gradually a myth grew around them. Fate of the Cyclops in 1918 left us with the enigma of a vanished steel giant. But the story of the Atlantic mystery is not limited to individual cases. It evolves into something greater, a legend spanning centuries and continents. Tales of missing ships in these waters began to take shape as early as the 19th century, when seafaring connected the world through trade arteries. Sailors of the time shared stories of ships disappearing without a trace, passing them from mouth to mouth in portside taverns. Some even recalled entries from Christopher Columbus, who in 1492 allegedly saw strange lights from his compass near the Bahamas. Sd. Elmo's fire, electrical discharges that appear on masts and rigging during storms, is mentioned in his diaries as a natural phenomenon, but it is not connected to disappearances. And the stories of Columbus remain a myth. These rumors, born from the episodes we examined earlier, remained scattered until the 20th century breathed new life into them, linking old tales with modern vanishings. It was this myth that Vincent Gaddis shaped into a coherent picture, giving it a name known around the world. As technology advanced and reports of disappearances grew louder, these stories began to attract attention beyond maritime circles. Why? The 20th century, cases of vanishings had accumulated, especially in the Western Atlantic, where routes between America, Europe, and the Caribbean most often intersected. The press picked up each incident, adding details and speculation, which heightened public interest. However, the real turning point came later, when one person managed to unify these scattered accounts into a single narrative, giving them a name that would forever stick in the minds of millions. In 1964, the American writer Vincent Gaddis published an article in Argos, a popular sensational magazine, a cheap publication specializing in sensationalism, adventure, and unusual phenomena. The article was titled "The Deadly Bermuda Triangle" and introduced the term to a wide audience for the first time. Gaddis brought together cases like the Mary Celeste, the Cyclops, and others that had been discussed for decades, describing the area between Miami, the Bermuda Islands, and San Juan as a place where unexplained disappearances occur. He relied on archival data, newspaper reports, and maritime records. Adding a dramatic style that captivated readers. In the article, he explained the vanishings with a mix of science and imagination. He mentioned magnetic anomalies, referring to old stories of compass malfunctions, though he provided no solid evidence. He spoke of unusual weather phenomena, such as sudden storms, and hinted at underwater currents capable of dragging ships away. In some places, he suggested the intervention of extraterrestrial forces or mysterious energies, which particularly captured the public's imagination. The publication in Argos, with a circulation of hundreds of thousands, sparked a wave of interest. Readers, fascinated by the idea of a mysterious part of the ocean, began discussing it in letters, conversations, and even in the pages of other publications. Gaddis did not invent these stories. He simply gave them shape, a name, and a map, turning scattered events into a collective legend. His work inspired books, articles, and research, and the term Bermuda Triangle quickly spread beyond the United States. By the 1970s, the idea had become part of popular culture. Fueling curiosity about past cases and new incidents, he expanded the topic in his book Invisible Horizons in 1965, adding even more cases and speculations, reinforcing the image of the triangle as a mysterious phenomenon. The story of Gaddis and his article in Argos is preserved in original magazine issues and later publications by the author, including the 1965 book Invisible Horizons. These materials are based on real events, but they're sensational. Format and Gaddis's tendency to exaggerate, such as hints at the supernatural, without evidence, call their scientific rigor into question, as confirmed by comparisons with archival records. Thus, the legend was born, combining 19th century rumors with 20th century disappearances, creating the phenomenon we still speak of today. By the mid-20th century, these waters had become a stage not only for missing ships, but also for disappearing aircraft. Expanding the boundaries of the mystery into the age of aviation, one of the most famous cases that reinforced this reputation was Flight 19 in 1945. 5 U.S. Navy bombers and a rescue plane sent to assist them vanished into the air, leaving behind only fragments of radio transmissions and new questions that continue to intrigue minds today. On December 5th, 1945, 5 Avenger torpedo bombers took off from the Naval Air Station in Fort Lauderdale, Florida. It was a training flight under the command of Lieutenant Charles Taylor, a pilot with 2,000 flight hours, a veteran of the Second World War. On board were 14 people. Taylor, 13 cadets and instructors conducting exercises in navigation and bombing over the ocean. The mission was routine: fly to the reef, drop practice bombs, and return via the Bahamas. The route passed through the area between Florida, the Bermuda Islands, and the Bahamas, already known for its peculiarities. The weather that day remained clear, with light winds and good visibility, promising a calm flight. Takeoff occurred at 2 o'clock in the afternoon, and the group headed toward the reef. After 1.5 hours, the base began receiving alarming radio messages. Taylor reported that the compasses had failed. "We don't know where we are," he said. His voice sounded confused, unusual for an experienced pilot. One of the cadets added, "We're flying east, but we should be going west," indicating a deviation from the course. Then Taylor said, "The ocean looks strange. It doesn't look right." The transmissions became increasingly chaotic, with pilots speaking of lost bearings even though the sun was still shining. At 4:25, another message was recorded. "We are entering white water. We are completely lost." White water is a term that usually refers to foamy waves, but in clear weather this was inexplicable and remains a mystery to this day. After this, contact was lost. These messages were confirmed by base records. Although interference and overlapping voices distorted some phrases, the base responded immediately. At 6:20, the seaplane Martin Mariner, with 13 people aboard, took off on a search mission. This was a rescue aircraft equipped with enough fuel for long hours. After 20 minutes, the Mariner reported entering the search area, but soon contact was lost. That same evening, the U.S. Navy launched an operation. More than 20 ships and 250 aircraft searched an area of 300,000 square miles, including the Bahamas and the Gulf Stream. The search lasted 5 days, but no trace of the 27 people was found. The U.S. Navy investigation began the following day. They examined radio logs, the condition of the planes, and the weather. The Avengers were in working order before takeoff, with full fuel tanks. Taylor was suspected of an error. He might have mistaken the Bahamas for Florida and led the group into the open ocean, but the compass failures on all aircraft remained unexplained. The Martin Mariner could have exploded due to fuel vapors. The merchant ship Gaines Mills reported a flash in the sky at 6:30, but no evidence was found. The weather remained stable with no storms. Radio enthusiasts in Miami intercepted signals. One claimed to have heard the phrase, "It looks like we are over the Gulf of Mexico." Though this could not be confirmed, the case generated numerous theories. Officially, the Navy leaned toward the idea that the Avengers became lost due to compass failure, flew east, ran out of fuel, and that the Martin Mariner exploded. However, the popularity of the triangle fueled rumors. Newspapers of the 1950s suggested the mission might have been secret, a test of new weapons or reconnaissance over the Caribbean, although Navy documents confirmed it was only a training flight. Other theories included alien abduction. White water was interpreted as traces of an alien ship or a portal. There were also speculations about temporal anomalies transporting the planes to another dimension, fueled by imaginations after Gaddis's article. These ideas had no evidence but were widely discussed in the press and books. This case was just the beginning of a series of aviation disappearances. 3 years later, in 1948, A Douglas DC-3 passenger plane vanished in the same waters, leaving only a brief radio message and 32 people missing. This story adds a new layer to the chronicle of the unexplained, taking us deeper into the age of aviation. On December 28, 1948, the Douglas DC-3 departed from San Juan, bound for Miami, Florida. It was a charter flight of the airborne transport airline, carrying 29 passengers, mostly Puerto Ricans returning home after the holidays, and 3 crew members under the command of Captain Robert Lindquist. The plane left San Juan at 10 o'clock in the evening local time, with enough fuel for a 5-hour flight. The weather remained favorable, clear skies, light wind, and good visibility. Conditions were ideal for a night flight over 400 miles of ocean. The flight proceeded smoothly until midnight when the Douglas DC-3 made contact with Miami controllers. Lindquist reported, "We are 50 miles from you. All is well." This was the last message at that time. The plane was 180 miles from Miami, halfway through the Bermuda Triangle zone. After this, all contact was lost. No distress signals, no indication of problems. When the Douglas DC-3 did not land at the scheduled time around 2 o'clock in the morning on December 29th, controllers raised the alarm. A search operation began at dawn. The U.S. Navy and Coast Guard dispatched ships and aircraft to survey the route. The area covered thousands of square miles, including waters along the Bahamas and the Gulf Stream. Rescuers looked for wreckage, lifeboats, or oil slicks, but found nothing. One pilot reported a faint radio signal at 3 o'clock in the morning, which could have been from the Douglas DC-3, but it quickly disappeared and could not be confirmed. The search continued for several days, but no trace of the 32 people was ever found. The ocean fell silent again, hiding yet another mystery. The investigation by the Civil Aeronautics Administration faced a lack of evidence. The plane had passed inspection in San Juan. The engines were functional and fuel levels were normal. Lindquist was considered an experienced pilot, and both the co-pilot and flight engineer had good reputations. The weather that night remained stable with no storms or turbulence. According to reports from Miami and San Juan, the radio equipment had been checked before departure and was functioning properly. The only clue was the message, "All is well," which indicated no problems, yet contact was lost shortly afterward. The case generated various theories. Officially, mechanical failure was suspected, possibly engine malfunction or fire, although the absence of a distress signal argued against this. Some pointed to human error, a navigation mistake by the pilot, but the route was simple, and the night was clear. Soon, rumors fueled by the Bermuda Triangle's fame began circulating. People mentioned magnetic anomalies that might have disrupted instruments or sudden storms unrecorded by stations in newspapers of the 1950s. Theories of alien abduction emerged, linking the incident to Flight 19, though no evidence supported this. The story of the Douglas DC-3 is preserved in the reports of the U.S. Civil Aeronautics Administration and newspapers of 1948. These materials are based on controller testimonies and search data, but the absence of wreckage leaves questions open. The most plausible explanation is a technical malfunction leading to a rapid catastrophe, though the exact cause was never determined. In the last of the mysterious disappearances, we examine the boat Witchcraft, which vanished in 1967. This case occurred nearly 2 decades after the Douglas DC-3, bringing the Atlantic mystery into the era of modern technology. It stands out for its proximity to shore and the speed with which the vessel disappeared, leaving only silence where voices had sounded just moments before. On December 22, 1967, the Witchcraft yacht departed from Miami, Florida. It was a small vessel, 7 meters long, owned by Dan Baruch, a local businessman and boating enthusiast. On board were Baruch himself and his friend, Father Patrick Hogan. They planned a short trip along the coast to enjoy Miami's. Christmas lights from the water dot the yacht left the dock around 7 o'clock in the evening, heading toward buoy Number 7, located 1 mile from shore. At 9 o'clock in the evening, the Coast Guard received a signal from the Witchcraft. Baruch reported, "We have a problem. We hit something. Need assistance." His voice sounded calm without panic, indicating a minor issue, possibly the propeller, caught on a reef or debris. He specified his location near buoy number 7 and requested a tow. The dispatcher confirmed that help would arrive in 20 minutes and asked Baruch to fire a flare to aid in locating the vessel. Baruch agreed and communication ended. The Coast Guard arrived at the buoy at 9:19, 19 minutes after the call. The sea remained calm, visibility was good, and Miami lights glimmered in the distance. However, the yacht was nowhere to be found. There were no traces of the Witchcraft, Baruch, or Hogan. Rescuers searched the area for flares, wreckage, or fuel slicks, but found nothing. The search expanded to 200 square miles along the coast, involving Navy ships and aircraft. The operation lasted several days, but neither the yacht nor its passengers were located. The vessel, just 1 mile from shore, disappeared within minutes. The Coast Guard investigation encountered a complete void. The Witchcraft had been in excellent condition, recently inspected with an inflatable life raft and life jackets on board, which Baruch had no time to use. Buoy number 7 was in shallow water, about 5 meters deep, making sinking unlikely without a strong storm. The weather remained clear. The radio functioned and the signal was clear, ruling out a communication failure. Witnesses on shore saw the yacht's lights until 9 o'clock, but they vanished after the call. No reefs or obstacles were recorded. In the area, though Baruch mentioned a collision, the case spawned various theories. The Coast Guard speculated that the yacht might have sunk due to a hidden hull breach, but the lack of wreckage contradicted this. Local sailors suggested a strong current carried the vessel into the Gulf Stream, though its speed could not explain the disappearance in 19 minutes. Other rumors included alien abduction or a sudden whirlpool, but there was no evidence. In the press of the 1960s, some linked the disappearance to Flight 19, enhancing the mystique. These materials are based on radio records and eyewitness accounts, but the absence of evidence leaves gaps. The most plausible explanation remains a sudden malfunction or collision with an unseen object, though the exact cause was never determined. Disappearances in the Atlantic over the centuries have left humanity facing the unexplained, prompting a search for causes hidden in the nature of these waters. The Bermuda Triangle, marked by numerous vanishings of ships and planes, has become a place where science attempts to unravel the mystery. Among the hypotheses based on facts, magnetic anomalies stand out. This phenomenon is related to the peculiarities of Earth's geomagnetic field, which can affect navigation in this region. The Earth is surrounded by a magnetic field generated by the movement of molten iron in its core. This field directs compass needles toward magnetic north, helping sailors and pilots determine their course. However, the field is not uniform everywhere. In some locations, it is distorted due to geological structures or changes in its lines of force. In the area known as the Bermuda Triangle, a unique situation occurs. Here, true north, the geographic point where meridians converge, and magnetic north, determined by the field, are closer to each other than in many other parts of the planet. This convergence creates a zone where compasses can deviate from the expected direction. Scientists note that in this region, the difference between true north and magnetic north can reach 10 to 15 degrees. For an unprepared person relying solely on a compass, such a deviation could lead a ship or plane hundreds of miles off course. Historically, sailors recorded such malfunctions in the Western Atlantic as early as the 19th century, when instruments began giving inaccurate readings without any apparent reason. Modern geophysical studies confirm the existence of these anomalies. Magnetometers used in expeditions in the 1970s recorded local distortions near Bermuda and the Bahama Banks. These distortions are associated with underwater structures and the movement of magnetic lines connecting the equator and the poles. The scientific basis of this hypothesis relies on data about Earth's magnetic field. The National Oceanic and Atmospheric Administration notes that in the triangle, the field is subject to variations, which are amplified by geological features of the region, such as shallow banks and faults. However, these anomalies themselves are not destructive. They only affect navigation by misleading compass readings. In the 20th century, with the advent of gyroscopes and satellite systems, their impact became less significant, but for ships and planes of the past, which depended on basic instruments, this could pose a serious threat. The magnetic anomaly hypothesis has been preserved in geophysicists' scientific works, starting with field measurements in the mid-20th century. These studies are based on expedition data and observations of compass behavior at sea. It explains navigation failures, but leaves open the question of why some disappearances occurred even in clear weather or with experienced crews. This encouraged consideration of other scientific explanations, such as methane releases, which we will examine next. The next hypothesis takes us beneath the ocean's surface to methane eruptions, a natural process capable of drastically altering conditions at sea. This idea is based on seabed geology and offers a perspective on how some disappearances could have occurred instantaneously, leaving no trace in this restless corner of the planet. Methane forms deep within the sedimentary layers of the ocean floor, where organic remains from ancient algae to microbes decompose without oxygen. Under pressure, this gas transforms into clathrates, frozen structures resembling ice. In the Western Atlantic, such deposits are found in shallow areas and along the continental shelf, especially where tectonic faults disrupt stability. When temperature or pressure changes due to underwater shifts or currents, the clathrates break down, releasing gas bubbles that rapidly rise to the surface, sometimes forming columns hundreds of meters high. For ships, this creates a danger. Water saturated with methane bubbles loses density. Instead of the usual 1,000 kilograms per cubic meter, it becomes much lighter. A vessel in such a zone loses buoyancy and sinks within seconds, unable to send a distress signal. Laboratory experiments in the 1980s showed that even a small vessel could sink almost immediately during such an eruption. Scientists believe that large bubbles could also sink larger ships, with debris subsequently carried away by powerful currents like those flowing along the coast. Planes could also be affected by methane. As the gas rises into the atmosphere, it reaches flight altitude and alters its composition. An engine drawing in a mixture with a high concentration of methane may stall due to combustion failure. Turbulence from strong eruptions can destabilize flight. Geologists in the 1990s confirmed the presence of clathrates and sediments along the Bahama Banks, and underwater surveys revealed craters and faults, evidence of past gas eruptions. The methane eruption hypothesis is reflected in the scientific work of geochemists, starting from the 80s. These studies are based on seabed analysis, tank tests, and observations of eruptions in other seas. This hypothesis explains how ships could vanish without a trace, but it depends on a rare coincidence. The eruption must occur directly beneath the passing vessel. However, the ocean's surface hides other forces, no less formidable. Among them are rogue waves, nicknamed killer waves by sailors, which can rise up to 30 meters. This idea takes us to the movement of water masses, offering a perspective on how giant peaks could become the cause of disasters in this region. These waves form when winds and currents converge at a single point, amplifying each other. They can be 2 to 3 times higher than ordinary storm waves and appear suddenly. Calm seas can produce such a wall of water within minutes. For a long time, they were considered a myth until in 1995. A satellite recorded a 25-meter wave off the coast of Norway in the western Atlantic. Similar conditions are created by the collision of warm and cold currents, especially where winds from the land meet ocean currents. Research shows that in this zone, such waves occur more often than in some other parts of the world, due to the complex dynamics of the currents. Those who have encountered them and survived describe them as overwhelming. One sailor in the 1970s recalled how, off the coast of Florida, his ship was hit by a wave as high as a 10-story building. The vessel tilted almost to its limit but held, although everything on the deck was washed away. Others reported a sound like rolling thunder and how smaller boats vanished upon impact. These accounts demonstrate a force capable of breaking ships or dragging them underwater, leaving only rare debris. Oceanographers using satellites and buoys have established that along the paths of warm currents in the western Atlantic, the likelihood of rogue waves is higher. Models identify points where wave crests are amplified up to 30 meters due to wind pressure and currents. Aircraft at high altitudes remain out of reach of these waves, but low-flying machines may enter turbulent zones created by such waves. Scientific studies from the 1990s, based on measurements and eyewitness accounts, support this idea, pointing to the hidden power of the ocean that could have played a role in disappearances. Rogue waves reveal how massive walls of water can crush ships in the western Atlantic. Yet even after such strikes, the question remains, where do the traces vanish? The answer may lie in the Gulf Stream, a swift current moving at 8 kilometers per hour, carrying away everything that falls into its flow. This idea draws our attention to the movement of oceanic masses, showing how nature could erase the traces of disasters in this region. The Gulf Stream originates in the Gulf of Mexico and flows along the eastern edge of North America. Near the coast of Florida, it reaches a width of 100 kilometers and a depth of up to 800 meters, moving millions of cubic meters of water every second. Its speed of 8 kilometers per hour sets it apart from other currents, making it one of the strongest flows in the world. Warm waters, reaching 25 degrees Celsius, travel from south to north, curving around the Bahamas and heading toward Europe, forming an invisible ribbon that dominates this corner of the Atlantic. When a ship or airplane is lost, the Gulf Stream intervenes. Wreckage, lifeboats, or fuel slicks are picked up by the current and carried tens of kilometers within hours. For example, debris that fell off Florida could end up off the coast of North Carolina, 700 kilometers to the north, within a day. This makes rescue operations nearly futile. By the time teams arrive, everything has been carried far away or pulled under by whirlpools at the edges of the current. In the 1980s, oceanographers used drifting buoys to prove that objects in the Gulf Stream move at such speeds, and that turbulent eddies can drag them underwater. Sailors observed cargo from damaged vessels appearing hundreds of miles from the site of the accident. While the current does not threaten airplanes directly, it can carry away debris, complicating detection. This hypothesis is supported by measurements of speed, satellite data, and observations of drifting objects collected since the mid-20th century, showing how the ocean could conceal the consequences of disasters. The next step is to consider weather factors. Swift currents can carry away the traces of disasters in the western Atlantic, leaving rescuers empty-handed. However, these catastrophes often begin with forces acting above the water, not below. It Weather phenomena, hurricanes, and microbursts take us to the atmosphere, where wind and pressure create conditions capable of destroying ships and airplanes. This idea relies on the power of nature, which has left its mark in the weather. Archives of this region. Hurricanes are giant vortices that form over the warm waters of the Atlantic, where the surface temperature exceeds 26 degrees Celsius. They develop when moist air rises, cools, and condenses, releasing energy that twists winds to speeds exceeding 118 kilometers per hour. In the zone between Florida and the Caribbean, the hurricane season lasts from June to November, peaking in September. Archives from the National Oceanic and Atmospheric Administration document their destructive power. In 1969, Hurricane Camille struck the coast of Mississippi with winds reaching 300 kilometers per hour, breaking ships and flooding land with waves up to 7 meters high. Such storms are capable of sinking vessels and knocking low-flying aircraft out of the sky, especially if they enter the zone of the strongest gusts. Microbursts are another threat, smaller in scale but no less insidious. They occur in storm clouds, when cold air rapidly descends, striking the surface at speeds of up to 160 kilometers per hour. Unlike hurricanes, they cover only a few kilometers, but their force is concentrated. Wind pressure can capsize boats or damage airplane wings. Weather archives preserve an example from 1982. When a microburst off the coast of Florida tore a yacht from its anchor, hurling it onto the shore within minutes. Another case in 1978 was recorded near the Bahamas, where a fishing vessel sank under a sudden gust of wind, although no storm had been forecast. For aviation, microbursts are particularly dangerous due to sudden wind shear. Pilots entering such a zone during takeoff or landing face an abrupt loss of altitude. Meteorologists in the 1980s began recording these events using radar, observing their frequency during the warm months along the Atlantic coast. Hurricanes, in contrast, leave a broader trail. In 1992, Hurricane Andrew passed through Florida, destroying dozens of vessels and ports and damaging low flying. Rescue helicopters. Data on these phenomena have been collected in the archives of the National Oceanic and Atmospheric Administration and Caribbean weather stations. They are based on radar readings, eyewitness accounts, and weather reports from the mid-20th century. However, the weather in this region also hides more subtle phenomena, noticeable only from above. Hexagonal clouds, observed in NASA data, bring us to turbulent zones over the ocean, where unusual structures in the sky can create dangerous conditions for those below. This idea relies on observations from space, revealing the hidden dynamics of the atmosphere above this part of the planet. Hexagonal clouds are unusual formations that stand out with clear edges, resembling honeycombs. They form when cold air descends into warm layers over the water, creating convective cells. Unlike chaotic storm clouds, these structures take on a geometric shape due to the even distribution of airflows. NASA recorded such clouds over the western Atlantic using the Terra satellite and the MADIS instrument, a moderate-resolution SPECTRORD IOMETER. In 1992. Images showed these clouds over the Bahamas with sizes ranging from 30 to 80 kilometers in diameter near areas where warm waters feed atmospheric instability. These clouds are associated with turbulence that can reach the surface. Meteorologists suggest that they generate descending air currents, so-called microbursts, but on a smaller scale than in thunderstorms. NASA data from 1992 indicated that such currents can produce winds of up to 160 kilometers per hour when they collide with the ocean, raising waves up to 14 meters high. Radar studies in the 2010s confirmed that turbulent zones over this region occur more frequently in warm months, when temperature differences between the water and the air increase. For ships, these conditions create hazards. Sudden gusts of wind can capsize boats or push them off course. Aircraft, especially at low altitudes, encounter abrupt wind shifts that disrupt control. Weather archives from the National Oceanic and Atmospheric Administration report cases in 1998 when a fishing vessel off the coast of Florida was hit by a sudden wind linked to a similar cloud formation, losing its cargo even though the sea had remained calm until that moment. The hexagonal cloud hypothesis is based on NASA satellite data and meteorological observations from the early 1990s. These materials rely on modest images and wind flow measurements, demonstrating how geometric clouds enhance local turbulence. They highlight the role of the atmosphere in creating hazardous zones, though their impact is limited to specific conditions. We turn to facts and figures to understand whether the Western Atlantic truly stands out among other maritime regions. The Bermuda Triangle has long been considered an area where disappearances occur more frequently than elsewhere, yet statistics allow us to examine this claim from a different perspective. Comparing it with other dangerous regions, such as the Dragon's Triangle, Cape Hatteras or Sable Island helps assess whether this part of the ocean is truly unique, or if its reputation is simply the product of sensational legends and heavy traffic. The Bermuda Triangle covers an area of approximately 1.5 million square kilometers between Florida, the Bermuda Islands, and Puerto Rico. In the 20th century, roughly 50 large ships and 20 aircraft were recorded as missing here, according to data from the National Oceanic and Atmospheric Administration and the United States Coast Guard. This figure includes both well-known cases, such as the disappearance of the cargo ship in 1918, and less prominent incidents, like small boats lost in storms. Thousands of vessels and hundreds of flights pass through the triangle each year, connecting the ports of Miami, San Juan, and Bermuda, making it one of the busiest corners of the Atlantic. For comparison, consider the Dragon's Triangle in the Pacific Ocean, located between the islands of Honshu, Okinawa, and Guam off the southeastern coast of Japan. Its area is approximately 600,000 square kilometers. And during the same 20th century, Japanese maritime archives record around 40 missing vessels, including 5 military ships in 1952 during exercises and the fishing vessel Maruno, 5 in 1954. The region experiences typhoons reaching speeds of 200 kilometers per hour and underwater, volcanoes associated with the Pacific Ring of Fire, creating conditions at least as severe as those in the Bermuda Triangle. Other areas are equally notable. Cape Hatteras off the eastern coast of the United States, known as the graveyard of the Atlantic, has witnessed more than 1,000 shipwrecks over 400 years, from 17th century sailing ships to 20th century tankers, such as the S. Grunsberg, which sank in 1942 during a storm. Maritime losses have spanned centuries. Sable Island, located 600 kilometers off the Canadian coast, has claimed 350 vessels over 300 years due to shallow shoals and dense fog, including the steamship Manhattan in 1806. The Drake Passage between South America and Antarctica covers an area of approximately 1 million square kilometers. It loses dozens of ships annually due to 20-meter-high waves and winds up to 150 kilometers per hour, such as the trawler Northern Wind in 1980-5. Larry Kush, in his book, calculated that the percentage of disappearances in the Bermuda Triangle does not exceed the average for busy shipping lanes. According to the United States Coast Guard, around 100 large ships were lost worldwide each year during the 20th century, and only 5 to 6% occurred in the Triangle Dot in the Dragon's Triangle. The numbers are similar. Japanese reports indicate approximately 3 to 4 unexplained disappearances per year until the 1980s, often linked to typhoons or navigational errors. At Hatteras and Sable, losses are higher due to natural hazards, shallow waters, and fog, but these areas are not surrounded by myths. Modern technology, such as satellites, radar, and rescue systems, has reduced the number of incidents in the triangle since the 1990s to 2 or 3 per year, comparable to other regions. However, numbers are only part of the picture, and direct evidence from the depths is required for a complete understanding. Let's draw the conclusion. What remains of the Bermuda Triangle legends when facts take precedence? Science has provided answers to many questions, but has it left room for new mysteries? Statistics show that the number of disappearances in the triangle is no higher than in other busy maritime areas. Underwater expeditions and modern tools have revealed that wreckage is rare, and the seabed is more often empty than full of traces. The National Oceanic and Atmospheric Administration and the United States Coast Guard note that most disappearances around 80% are linked to weather, crew errors, or mechanical failures, storms, navigational mistakes, and equipment malfunctions explain the fate of ships and aircraft, leaving little room for fantasy. Larry Kush, in his book, argued that the triangle is a myth grown from sensational stories. Modern data confirms that since the 1990s, the number of cases has dropped to 2 or 3 per year, thanks to satellites and radio communications. However, some disappearances remain unexplained, and depths of up to 3,000 meters still hold their secrets. Only a small portion of the seabed has been explored. Science sees the triangle as an ordinary part of the ocean, yet its legend continues to live, leaving room for reflection. Thank you for joining us on this journey, exploring the mysteries of the Bermuda Triangle from legends to facts. If you enjoyed it, subscribe to the channel, like, and share your thoughts in the comments. See you next time!